Hi everyone. So today's lesson is about taking what we've been learning about roots and discussing what they look like as exponents. So today we're going to be talking about rational exponents. Um, Rational exponents are exponents that are fractions. So I like to call them fractional exponents. So let's determine what a fractional exponent actually means and what you might be more familiar with. The definition of b, any number raised to the 1/2 power, actually means the square root of b. So if I give you 9 to the 1/2 power, it means the square root of 9. All right, let's move down. B to the 1/3 then would mean what we've been working with this week, the cubed root of b. So if I give you a number like 27 to the 1/3 power, that actually means the cubed root of 27, making sure I put that index inside the radical. All right, so what do you think b to the 1/5 would be? Well, b to the 1/5 would mean the 5th root of b. All right, where it gets a little bit trickier is when there's not a 1 on the top. So, for example, and I'm sorry I'm going out of order here, the definition of b to the 3/2 power. The bottom number takes on the index, and the top number is what it's raised to. So b to the 3/2 power is the same thing as the square root of b quantity cubed, and the whole thing being cubed. So what we can say as a definition for rational exponents, b to the p cubed means the q root of b quantity to the p, okay? All right, so let's look at what this means. If I want to, so rational exponents, I give you a raised to the m over n. That means the nth root of a to the m power. All right, that's considering that it's a positive exponent, but we've also got this idea of negative exponents. So the first thing we want to remember is that if it's a negative exponent, we flip it, so we bring it down. In this case, we're going to bring it down to the denominator, so we have a to the mn. And then if we were going to write that as a root, its definition really means 1 all over the nth root of a to the m power. All right, so let's try this. I want you to try to rewrite root 9 to the 3 power using exponents, and I want you to try rewriting using radicals. So press pause, try it, and let's see if we got it right. Okay, so you're back. So this says the square root of 9 to the 3 power. So remember, the index goes on the bottom of the fraction, and the power that it's being raised to goes on the top. So this should have been 9 to the 3/2 power. All right, if I want to rewrite using radicals, 16 to the 5/3 would mean the cubed root of 16 to the 5 power. All right, so we're going to be moving backwards and forwards between all of these different radicals, okay? And fractional exponents. So let's try some. Evaluating expressions with rational exponents. If I have 9 to the 3/2 power and I ask you to evaluate it or simplify it, that means find the number. So I have, this becomes the square root of 9 to the 3 power. The square root of 9 is 3, so 3 cubed is going to give me 27. So that's how I'm going to evaluate expressions with rational exponents. All right, let's try this next one. 16 to the 5/2. All right, so that gives me the square root of 16 to the 5 power. The square root of 16 is 4. So 4 to the 5 power, that isn't actually one I've expected you to know. If you grabbed your calculator, you're going to find out that it's 4 times 4 times 4 times 4 times 4, so 1024. All right, you try the next one. You press pause and try it. Okay, so you're back, and hopefully you did the 5th root of 32 squared, which would give me the 5th root of 32 is 2, so 2 squared is going to give me 4. All right, so then I threw in the negative exponents. So you have a couple of options. There's two ways to do it. I'm going to show you the way I just showed you. The first thing we would do is we'd flip it and make it so 1 all over 64 to the 2/3, then evaluate it. So 1 all over the cubed root of 64 quantity squared. So the cubed root of 64 is 4, so 1 all over 4 squared is 16, 1 all over 16. All right, now you try it with 16 to the negative 3/4. Press pause and try it. Okay, so you're back, and what you should have done is first written it 1 all over 64 to the 3/4, and then evaluate it. So 1 all over the 4th root of 64. I'm sorry, 16. I did 64. I apologize. I made a mistake there. So 1 all over 16 to the 3/4. And then 1 all over the 4th root of 16 cubed. All right, the 4th root of 16 is 2. So 1 all over 2 cubed is going to give me 1/8. Okay? All right, now we also can evaluate expressions that have exponents that are fractions without turning them into radicals, but by using the laws of exponents. So remember the laws of exponents, if I have bases are the same and I have power times a power, we add them high. So this would become 7 to the 1/2 plus 1/2. 1/2 plus 1/2 is 1. So this is 7 to the 1 power, which is just 7. All right, I do kind of want to go through the laws of exponents that you see on the next page. I want to review the properties again and show you now how they're going to look with rational exponents. So we know that the property a to the m times a to the n gives me a to the m plus n. Power times a power, add them high. All right, so how do we apply that? That would give me 3 to the 1/2 plus 3/2. Yes, we have to add fractions, which is going to give me 3 to the 4/2, which is 2. So 3 squared. So my answer would be 9. Now I'm doing every step. Some of it you could do in your head, but you are going to have to show me some of the work. Like I want to see the addition of the fractions, but you can do 4 divided by 2 in your head. All right. Power to a power, in the next example, we multiply the exponent, so a to the mn. So in this case, this would be 4 to the 3/2 times 2. Well, 2's over 1, the 2's cancel, so I get 4 to the 3 over 1, which is 4 to the 3 power. 4 to the 3 power is 64. So again, those numbers and those powers that I keep talking about are really important. All right, a to the b, ab to the m power means a to the m, b to the m. I tend to want you to do everything in the parentheses first, so this one can actually be done 2 ways. You could do 9 times 4, which is 36. 36 to the 1/2 means the square root of 36, which is 6. You also could distribute in this case and do 9 to the 1/2 times 4 to the 1/2. And we know the square root of 9 is 3, and the square root of 4 is 2, and then multiply them and get 6. You'll get the same answer both ways in that case. All right, so now we have a to the negative m. A to the negative m would be 1 all over a to the m. So we have 1 all over 25 to the 1/2 power. Anything to the 1/2 power just means the square root. So I have the square root of 25. The square root of 25 is 5. Okay, a few more. All right, a to the m over a to the n. Remember I said bring the smaller to the larger and subtract. So to the m minus n. So we have 6 to the 5/2 all over 6 to the 1/2. That's going to give me 6 to the 5/2 minus 1/2, which is 6 to the 4/2, which is 6 squared. 6 squared is 36. All right, last one. Remembering that if you have a fraction raised to an exponent, you have to make sure that exponent gets to everything inside as long as you've done everything inside first. I have 8 over 27 to the 1/3 power. This means the cubed root of 8 all over the cubed root of 27. The cubed root of 8 is 2. The cubed root of 27 is 3, so my answer is 2/3. Okay, so hopefully you have an idea, you can see what these fractional exponents do. You're very good now at this point with the laws of exponents, so applying them is a little bit easier. But if you feel like you need a kind of a redo, now that you've taken the notes, go back and rewatch the video and see if it just kind of solidifies a little bit more for you. And tomorrow we're going to be practicing in class. All right, have a great day.